Hello, everyone. Today we're going to talk some about the U.S., land of the world's most powerful military, incredible technologies, scientists and engineers the world cannot match, and a great debate about just what is a fact. I am, of course, referring to greenhouse gases and are the numbers real? So I'm going to flip up here some statistics, and I will say right now, there's the good numbers, the medium numbers, and the numbers I don't know about. Looking at this slide, there's some good information in there that gives you an idea of where a lot of our greenhouse gases come from. People get too hung up on the specific number of any one line. They're good for relative statements. Uh, I've taken the time to look at where the numbers come from, how they're put together. Like any statistic, you can manipulate them a little. Most of them seem pretty good. One number on there that's got me wondering, and it's going to be a topic of a future video, is going to be the whole land use number that's negative. That seems to me to be somewhat iffy, and I would ask those people out there who are thinking that climate change numbers are something where the books are cooked, if you will, to remember that my experience so far has been if people are playing with the numbers, it's to make it look not as bad as it is. So, the climate process, how the Earth's atmosphere is affected by greenhouse gases and a whole lot of other things, the sun, orbit, in terms of the temperature on this planet, it is a very complicated process. So no one should feel when they're listening to it that, hey, it's difficult to follow. You should be suspicious of anyone who says it's either true or not true because A is the biggest factor and it leads directly to B. There's a lot of dependencies. It's complicated. Having said all of that, there are solid facts behind greenhouse gas and their impact on temperature. One of the first things sometimes you'll hear is, well, the old correlation is not causation. Okay, and the analogy that's thrown out there is more people drown on hot days and more people eat ice cream on hot days. And those two things are correlated, but they're not causative. Okay, fair enough. But if someone told me that more people drowned on a hot day, they may mention the ice cream, but I think no matter what, it'd still be a good idea to put a lifeguard on the beach while we try to figure out what the problem is. So, correlation is a reason to pay attention and investigate. It's not something that should be ignored and dismissed just because you don't know the cause. Thermodynamics, the study of how temperature interacts, and infrared technologies are well understood. These are not soft science, these are hard science used every day in everyday products. Think of your air conditioner. You have any doubt about infrared? Hey, infrared goggles in the military work because we understand how that works. Carbon dioxide, methane, greenhouse gases, they're all directly measurable. They're going up, and the impacts are understood. These are hard facts. So, I also was reminded while at a bar in Key West that, hey, just because you want to talk about greenhouse gases, did anyone ever think that fossil fuels didn't have side effects? He was someone who'd worked on cleanup sites for the EPA for a long time. He did remind me of the fact that this is just the latest in a line of issues, which shouldn't surprise us. When you use a lot of any substance, there are always side effects. It also brings up the question of you probably don't want to go to a bar with me in Key West if I'm going to talk about greenhouse gas. So let's turn now to the subject of estimates. Estimates have wiggle room. That's why they're called estimates. And some of them are better than others. So I think of them when I'm talking about greenhouse gases. And in any video of mine you're seeing, Estimates to me are ROMs, which stands for rough order of magnitude, at least when you're in the military. That's what you use it for. And it gives you an idea of roughly how important a greenhouse gas source might be. So, when a scientist does an estimate of how much greenhouse gas, carbon dioxide in this case, is put out by a car, I don't trust that the number is exactly right, but it is certainly useful to know that it's a very large 10 to 20% source of greenhouse gases. So it's good to know what a ROM is. It doesn't mean it's precise. So models are another estimate. They are not 100%. They are good for rough order of magnitude. They give me an idea of where things are headed. If they have a concern to me, it's that they probably understate the problem, not overstate it. Recent events would tend to back that up. My own experience with statistics tells me that I think the scientists get a little too involved with false precision, if you will, that there's more error and that the error is going to end up being on the high side. If I do have a gripe about some of the videos and when I listen to things on TV about the advocates, activists, and scientists when they're talking about the climate, is they get a little too passionate, a little too emotional, and a little too much in the way of advocacy. And I do think that turns some people off. So if you're one of those folks who are like, "Hey, this person sounded preachy to me," they, yeah, I kind of get what you're saying, and need to watch that. When you're dealing with a tough subject, I had to do that when I was in the military as a project manager, and you have someone telling you, "I need this equipment, I need it now because people are dying in the field," but part of your project is a long term one, and you have to weigh today's problems versus problems 10 years from now. You have to make tough choices. And the issue of the climate and greenhouse gases is full of them. Which brings me to my last footnote on the whole subject of estimates and when people are talking about the quote unquote facts of the climate and how greenhouse gases affect. Normally, scientists are not involved as heavily in the implementation. They develop the techniques and then engineers go and look at the details for implementation. One of the problems is right now we pretty much have to use climate scientists because there really is no one who is a climate engineer. We haven't ever terraformed a planet before. And scientists are different than engineers. And frankly, implementation is not their forte. So, scientists, bear that in mind when you're talking about the subject. When you're listening to a scientist, temper that they're doing the best they can. They're coming at it from a somewhat different perspective than maybe you're used to hearing. So let me use a bit of an analogy here to help folks understand when talking about the climate, what happens when a system goes out of balance. On your screen, there's a picture of an airplane. That airplane, as the story goes, had its engines removed for maintenance. And while it was left there on the runway, a gust of wind came and tipped it on its tail. Of course, stories are stories, the details may vary, but why would something like that happen? Clearly, the plane's on its tail. Well, that's because weight and balance on an airplane is a complex problem, and the details matter, right? How many people are up front, how many people are in the back. It also could be that no one, when they were looking at designing the airplane, thought about changing the engines on a runway where a gust of wind might happen with the flaps down. That may just not be, it may have gotten missed. So it's both an example of when something goes wrong in the climate and you hit the quote unquote tipping point, it's not going to just go back on its wheels because the wind stops. It also is where you can have done the best job with the math you can, but little things make a difference. If you didn't anticipate the particular set of circumstances, you may have an unexpected consequence. So, for a video where I'm going to evaluate the US on my climate model rating, I've spent a lot of time talking about facts, statistics, and estimates. That's because for the US, that is a big deal in terms of deciding what to do going forward. But let's get to the actual ratings, and I'll talk to it in a general sense on each area that I see. I also would say that most of my other videos tend to be somewhat US centric. So when you listen to them, when I'm talking about solar, I'm talking about it in a US context. When we're talking about EVs, it tends to have a US bent. Yes, to try to touch the world, but it is a US centric channel I run. So there is a lot of good info on those other videos that are not needing to be repeated here. So first score up is carbon intensity. And as I've mentioned in my other video, the carbon intensity for the US, which is a measure of emissions versus gross domestic product, wealth in other words, has been moving in the right direction. It's come down significantly over the past 10, 20 years. Not as much as it needs to, not by a long shot, but you get a decent score. So 5 on carbon intensity. Now, for in terms of cumulative emissions, the U.S. is at 25%, and that's number one, and that's not the category to be number one on. Not even going to go through the slide with that number, even if it's wrong by a bit, the U.S. gets a 0. So for 2030 goals, well, the U.S. has a goal of 40% reduction. That's not going to happen. 20%, and that's probably best case. So get another decent score here. Progress is being made. The US, probably more than most countries, is having a shiny object problem, I would say, where we're having trouble staying focused and making long-term plans on a lot of things, not the climate just being one of many. It's EVs today, then it's not EVs. You hear how great they are. Elon Musk is a topic. One day he's a hero, the next day he's not. Unfortunately, this chasing the shiny object is causing us to not stick with the course. Greenhouse gases are something that is a long-term problem. I frankly object to the word crisis because when you talk about a crisis, it's usually something that's a 1-2 year issue. That's not the case with this. This is a 70-year project that's going to be underway. So what I said about 2030 applies to 2060. Same deal, sticking to a path. The odds that net zero is going to be achieved, I do not think are high. Do I think improvements are being made? Yes. Is the US likely to continue to get better? Yes. Is it going to do so nearly at the rate that everyone wants it to be? No. So all of these numbers bring the US to an overall score of 4, which puts it above China, but definitely not where it needs to be. So I hope you found this video informative. Please give me your feedback, like, comment, or subscribe. Thank you, and talk again another day.